Welcome, space enthusiasts. Today we're journeying to the largest planet in our solar system, Jupiter. A gas giant of immense proportions, Jupiter is home to one of the most fascinating and enduring phenomena in the cosmos, the Great Red Spot. This colossal storm, larger than our entire Earth, has been swirling relentlessly in Jupiter's turbulent atmosphere for at least 300 years, possibly even longer. First observed by astronomers in the 17th century, the Great Red Spot has become an iconic symbol of Jupiter, a fiery eye in the midst of the planet's striped facade. Over the centuries, it has captivated the curiosity of scientists and space enthusiasts alike, a celestial mystery that continues to reveal new insights about the atmospheric dynamics of gas giants. Now that we've touched down on Jupiter, let's delve into the mysteries of this fascinating celestial hallmark. The Great Red Spot, a storm so massive it could swallow Earth whole. A tempest of such colossal proportions doesn't just occur overnight. Its formation is shrouded in mystery, with theories suggesting that this giant anticyclonic storm could have been brewing for centuries, possibly even millennia. One popular theory posits that the Great Red Spot is a permanent feature of Jupiter's atmosphere, drawing its energy from the planet's intense heat and rapid rotation. The storm churns and roils, but never dissipates, thanks to the turbulent forces at play in Jupiter's gaseous envelope. It's a bit like a spinning top that keeps going as long as there's enough force to drive it. However, unlike the short-lived storms we're familiar with here on Earth, the Great Red Spot has shown a remarkable longevity. It's been continuously observed for around 300 years, and some historical records suggest it might have been spotted as far back as the 17th century. That's a storm that's been raging longer than some countries have existed. Now, let's put this into perspective by comparing it with other storms in our solar system. Saturn's Great White Spot, for instance, is a tempestuous beast in its own right, but it only appears once every Saturnian year, roughly every 30 Earth years. It's a fleeting tantrum in comparison to Jupiter's enduring tempest. So, why does the Great Red Spot persist? Well, it could be due to the unique conditions on Jupiter, with no solid surface to create friction and slow the storm down, and a steady supply of heat from the planet's interior. It's the perfect recipe for a never-ending storm. But even this grand old tempest isn't immutable. Recent observations have shown that the Great Red Spot is slowly shrinking, prompting questions about its future. Will it continue to rage on for centuries more, or are we witnessing the final chapters of this cosmic phenomenon? So, you see, the Great Red Spot is not just a storm, it's a centuries-old marvel. Scene script. Let's paint a picture of the Great Red Spot. Imagine a swirling tempest so large that you could fit 2 Earths comfortably inside. That's the colossal size of this iconic Jovian storm. Its shape, a bit like an elongated oval, stretches about 16,000 kilometers in its longest diameter. That's more than 1.3 times the diameter of Earth. Now, let's talk about its color, the feature that gives the Great Red Spot its name. The spot sports a striking red hue, a fiery contrast to the pale yellow and white bands of Jupiter's atmosphere. The specific shade of red varies from brick to salmon, depending on the storm's mood and the viewing conditions. Scientists believe that these color changes could be due to slight variations in the storm's temperature, its chemical composition, or even the altitude of its cloud tops. But the Great Red Spot isn't a static picture. It's a dynamic, ever-changing spectacle. Historical observations show that the spot has been shrinking slowly for at least the past century. 100 years ago, the spot was about 40,000 kilometers wide. Today, it's less than half that size. Yet despite its decreasing size, the storm's intensity doesn't seem to be waning. The winds at its outer edge whip around at speeds of over 400 kilometers per hour, making it one of the most violent storms in the solar system. So, think of the Great Red Spot as a turbulent and tempestuous artist, painting with clouds and winds on a giant Jovian canvas. Its size, shape, and color are its signature, a signature that has evolved and will continue to evolve over time. The Great Red Spot is a dynamic, ever-changing spectacle. Jupiter's atmosphere is a tempestuous world, and the Great Red Spot is its crown jewel. This colossal storm, churning in the gaseous envelope of the giant planet, is a testament to the unique atmospheric conditions that exist on Jupiter. The atmosphere is primarily composed of hydrogen and helium, similar to the Sun, but it's the trace amounts of other elements that create the stunning visual spectacle we associate with Jupiter. One of the most remarkable aspects of Jupiter's atmosphere is its dynamic nature. The planet's rapid rotation, a day on Jupiter is just under 10 hours, combined with internal heat rising from the planet's core, results in a turbulent, fast-moving weather system. This system manifests as alternating bands of clouds that encircle the planet, creating a striped appearance. Now imagine this. Amidst these already chaotic weather patterns, a storm rages on for centuries, if not millennia. That's the Great Red Spot for you. This persistent anticyclone, a high-pressure region, is perpetually caught between two jet streams that are moving in opposite directions. This unique location prevents the storm from dissipating, allowing it to continue its dance across Jupiter's southern hemisphere. The Great Red Spot is not just a solitary performer, though. Other smaller storms and vortices interact with it, sometimes even being absorbed. This dynamic interaction contributes to the longevity of the Great Red Spot, constantly feeding the storm with new energy. The colors of the Great Red Spot, ranging from pale pink to deep red, are another intriguing aspect of Jupiter's atmospheric conditions. The exact cause of these colors remains a mystery, but they're likely due to chemical reactions involving the trace elements in Jupiter's atmosphere, driven by solar radiation. In this swirling maelstrom of gaseous bands and raging storms, the Great Red Spot stands as an emblem of Jupiter's atmospheric might. These weather patterns make Jupiter's atmosphere a fascinating realm to study, so as we continue to probe the mysteries of the largest planet in our solar system, one thing is certain. Jupiter's atmosphere, with its Great Red Spot, will continue to captivate us with its dynamic beauty and complexity. The Great Red Spot has captivated astronomers for centuries. This iconic storm on Jupiter has been the subject of countless observations and studies, each contributing to our understanding of this fascinating celestial feature. Our journey into the observational history of the Great Red Spot takes us back to the 17th century, when it was first observed. The Italian astronomer Giovanni Cassini is often credited with its discovery in the late 1600s, though it was not until the 19th century that the spot's red color was noted. In the 20th century, our knowledge of the Great Red Spot expanded exponentially with the advent of spacecraft missions. The two Voyager missions of the late 1970s provided the first close-up images of the spot, revealing its intricate cloud patterns and enormous size. The Galileo orbiter, launched in 1989, was the next major mission to study Jupiter and its Great Red Spot. Its findings helped to deepen our understanding of the storm's structure, dynamics, and longevity. The most recent significant contributor to our knowledge of the Great Red Spot is the Juno spacecraft. Launched in 2011, Juno has been sending back stunning images and valuable data about the spot, enabling scientists to study it in unprecedented detail. Key astronomers and spacecraft missions have played crucial roles in our understanding of the Great Red Spot. But it's important to remember that countless amateur astronomers have contributed as well. Their meticulous observations and recordings have provided a consistent record of the spot's changes over time, proving invaluable to the scientific community. From the early telescope observations of Cassini to the cutting-edge data from Juno, our understanding of the Great Red Spot has evolved dramatically. Each observation, each mission, and each discovery has added another piece to the puzzle of this captivating storm. Our knowledge of the Great Red Spot is the result of centuries of meticulous observations and cutting-edge space missions. And as we continue to explore the universe, who knows what other fascinating discoveries await us? What makes the Great Red Spot great? Well, it's all about what's brewing beneath the surface. This colossal storm is a vibrant mix of chemicals and elements, each playing a crucial role in giving it its distinctive color and character. For starters, the spot's iconic red hue is believed to be the result of complex chemical reactions. Sunlight interacting with ammonia and other compounds in Jupiter's upper atmosphere produces a variety of color-changing compounds. This process, known as photochemical reactions, is a bit like nature's own version of a color-changing light show. Further down, the spot's composition becomes even more intriguing. It's a swirling soup of molecular hydrogen and helium, sprinkled with dashes of water, methane, ammonia, and other trace elements. These elements, under extreme pressures and temperatures, create a dynamic, ever-changing environment. So the Great Red Spot isn't just a storm. It's a testament to the power of chemistry, a living laboratory of gas giant atmospherics. The Great Red Spot is a chemical cauldron brewing with complex interactions. Let's journey with Juno to the heart of the Great Red Spot. Launched in 2011, the Juno spacecraft has been tirelessly studying Jupiter, the gas giant. One of its prime objectives is to explore the enigmatic Great Red Spot, that tempestuous storm that has been raging for centuries. Juno's role in studying Jupiter is akin to a detective unearthing clues about an ancient mystery. Armed with technologically advanced instruments, Juno has been making close flybys of Jupiter and the Great Red Spot, gathering critical data and images. These flybys, known as perijoves, have allowed us to examine the Great Red Spot in unprecedented detail. So what has Juno unveiled? Quite a lot, actually. For starters, the spacecraft has shown us that the Great Red Spot extends much deeper into Jupiter's atmosphere than previously thought. Imagine a storm so intense that it penetrates deep into the very heart of a planet. Juno's microwave radiometer has given us this astonishing insight. Another revelation from Juno is about the storm's temperature. We've learned that the Great Red Spot is colder at the top and warmer at the bottom. This temperature difference is likely what's driving the storm's ferocious winds, which can reach speeds more than twice the maximum wind speed of a Category 5 hurricane on Earth. Moreover, Juno's findings have shed light on the storm's complex motion. The Great Red Spot doesn't just rotate, it oscillates, it changes shape, and it even changes color. All these dynamics are interconnected, contributing to the longevity of this magnificent storm. The Juno mission has also revealed the role of water in Jupiter's atmosphere. The presence of water is crucial because it's associated with the formation and evolution of giant planets. So, we can see how the Juno mission, by studying the Great Red Spot, is not only helping us understand Jupiter better, but is also offering valuable insights into the very nature of our solar system. With the Juno mission, we're peeling back the layers of the Great Red Spot, unlocking its secrets. It's been a whirlwind journey through the Great Red Spot. We've traversed the tempestuous atmosphere of Jupiter, delved into the crimson heart of this astronomical wonder, and learned about its tumultuous history. We started with the basics, introducing Jupiter, the largest planet in our solar system, and its most iconic feature, the Great Red Spot, a storm that has raged for at least 3 centuries. We then explored the theories behind the formation and longevity of this storm, a phenomenon that has bewildered and fascinated scientists for generations. We touched on the physical attributes of the Great Red Spot, from its immense size to its ever-changing shape and color. We also discussed Jupiter's atmospheric dynamics, a unique environment that sustains the existence of this grand storm. History showed us the key astronomers and spacecraft missions that broadened our understanding of the Great Red Spot. We also delved into the scientific theories regarding the composition of the spot and how elements and chemicals contribute to its distinctive red hue. We drew parallels with Earth's storms, highlighting both similarities and differences. We also talked about the Juno spacecraft mission's role in studying Jupiter and the recent discoveries it has brought to light. In the grand scheme of planetary science, studying the Great Red Spot is of paramount importance. Its existence and endurance challenge our understanding of atmospheric dynamics. It serves as a living laboratory for learning about weather patterns not only on Jupiter, but also on other gas giants in our solar system and beyond. As we gaze into the future, scientists predict various scenarios for the Great Red Spot. Will it continue to shrink? Will it disappear entirely? Or will it surprise us with unforeseen changes? Only time and continued observations will tell. As we continue to study this colossal storm, who knows what mysteries we'll uncover next? Until then, keep exploring, keep learning, and keep looking up.